All right, hello and welcome to our algebra lesson for today. This is algebra lesson 4-4. We're going to talk about graphing a function rule. All right, so we're going to go ahead and get started as we always do with our anticipatory set. So for our anticipatory set today, we're going to talk about, surprise, surprise, high school football. It seems you can't get away from that from my anticipatory sets. It seems like all my anticipatory sets are about football somehow, but here we go. So if I remember back in high school, I had a pretty good season one year as a receiver. I was always very, very excited about it. I would love to go ahead and tell people that I had 9 touchdowns at one point. I caught 9 touchdowns. That was great. Great time. Every time I caught a pass in the end zone, got a touchdown. It was fantastic. I loved it. I had a friend on my team who he went ahead and played receiver too. He was very good as well, but there was always something that bugged him. He one time played a game where he was wide open in the end zone, no one guarding him, no one around. He was running down the field in the end zone, threw a pass to him. He caught it in his hands, but it slipped out of his hands. He tried to catch it again. He sort of had his feet in, and he dropped it. It was horrible, and he always hated that. So he would like to tell people that he had 6.5 touchdowns. And of course, you can't quite have half a touchdown. You either score a touchdown or you don't score a touchdown. So obviously, when he would tell people that, there would be other people who would be, well, very confused. Because you can't have half a touchdown. You can only score touchdowns. If you don't catch it, it's not a touchdown. So you really had 6. Anyway, that's all we're going to talk about today, because as we go on and move in, you'll see how sometimes we look at data and data will have every possible solution. We can have 6.5, 6 3/4, or there's sometimes data where you can only have it in increments of 1 or in increments of however many we're talking about. So that's what we're going to talk about today, talking about these function rules that we have. So let's go ahead and get started by learning our standard for today. And there are actually 3. So we have 3. Okay, our first standard, this one's kind of new. This one is F.IF, so functions, introduction to functions, 0.5. So that's our first one. And the first one says, relate the domain of a function to its graph. And where applicable, to the quantitative relationship it describes. Okay, so that's our first one. That one's not too difficult to understand. Basically, all it's asking us to do is to find the function and match it to a graph. Which function goes to a graph and which graph goes to a function. Our next one, we have done this one before a little bit ago, N.Q.1. And this one states, use units as a way to understand problems and to guide the solution of multi-step problems. And then we have a little bit more. Choose and interpret units consistently in formulas another semicolon, choose and interpret the scale and origin in graphs and data displays. All right, so that one's a little longer, a little bit more confusing. It's a little bit more that we're talking about here. So this one, we're using units as a way to understand problems. So that just means that we're using different units. Feet, miles, in this case, touchdowns, right? We're using units as a way to understand problems, right? If I know, for me, I know if I score a touchdown, I know what that means. It helps me understand the problem. Okay, and then it says to guide the solution of multi-step problems. Okay, and that's what we're talking about here, where is it something where we can measure in whole numbers, or is it something we can measure half of? Well, in our anticipatory set, 9 touchdowns, you can only count touchdowns in whole numbers because you cannot score half a touchdown. Okay, so that's that second part. Guide the solution of multi-step problems. Then choose and interpret units consistently in formulas. Knowing what units formulas use, very important. And finally, choose and interpret the scale and origin in graphs. So in a graph, is our y-axis going to go up to 1,000? Is it going to go up to 10? Is it going to go up to 20? We have to decide that, okay? And our final standard for our lesson today is A.REI.10. Okay, this one's a little shorter. Won't take us so long to write it. Understand that the graph of an equation in 2-variable is the set of all its solutions plotted in the coordinate plane. Often forming a curve. Okay, so we've used this one before. I believe actually our last lesson used this one. But this one's asking and telling us that we need to understand that a graph of an equation in 2 variables, which remember means x and y variables, is the set of all its solutions. So you just plot the solutions on a graph, and it shows you what the graph is showing. Okay, I guess that's not the right way to say that. It will show you the solutions, and sometimes it will form a curve. A curve, remember, can be a straight line. Okay, so let's go ahead and get into our input. We actually do have some language of the discipline today. So in our input, go ahead and get my language of the discipline here. Okay, and our first term is continuous graph. A continuous graph. And a continuous graph is a graph that is unbroken. Seems simple enough. If it's continuous, that means it is unbroken. Okay. Our next one is a discrete graph. And a discrete graph is composed of isolated points. It's composed of distinct isolated points. Okay, so there's two different types of graphs we're going to be talking about. One is continuous, one is discrete. So let's go ahead and take a look at two example graphs. Okay, so let's say one of our graphs looked like this, and our other one looked like this. Had the same x and y values. Okay, now let's say we're graphing these, and we find that on this graph over here, the points are here, 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 and here. Let's say we're talking about touchdowns. On this one, we're talking about, let's not say this one's touchdowns. I almost messed that up. This one will have the same amount of data there, so let me go ahead and put this in. Okay, so on these two graphs, this one, we're talking about the weight of something. The more you add bits and pieces of, let's say, pencil shavings. Oh, here we go. I got a nice little visual aid for you. Let's say I'm measuring pencil shavings. So I measure this, and it tells me how many pencil shavings and the weight that the actual amount of pencil shavings present. So when we do that graph, you can add tiny little bits of shaving. You have no idea. You don't need to put a certain amount. So on that one, this would be called a continuous graph. Now on this one over here, we're talking about touchdowns. You score 1 touchdown, 2, 3, 4. You can't score a touchdown right there. So we can't connect these points. This would be discrete because these are separate, isolated points. So we have one example of continuous graph and one example of a discrete graph. Okay, I am out of room. I'm going to go ahead and put this aside, get myself a new piece of paper, and let's take a look at what we're going to be doing today now that we have our language of the discipline down. Okay, so what we're going to start with, we don't have anything else to do with our detail or with our input. So I'm going to go ahead and draw our detail flower, and then I'm going to write modeling. Because this is going to be modeling. We're just going to see some examples here. Also, I'm going to go ahead and put our rules icon because there are steps that you do for each of these. Okay. So the first type of thing we're going to be going through and talking about is graphing a function rule. Okay. So let's say you are given a rule. We need to know how to graph this. I will say this is one of my favorite parts of math. Learning math, I think it's so much fun to find a rule and to try and solve that rule. I just think it's kind of like a riddle, and I really enjoy this. So I'm going to give us a rule of y equals -2x plus 1. So that's our rule. And we want to turn this little riddle into a graph. But there's two steps. Whenever you have a rule, the first step, which I kind of think of as the gathering clues part, is to make a table. So step one is always going to be to make a table. And this is sort of us following these clues. So my table is going to have x on one side, because x is our independent variable. If you look up here, y is dependent on what happens to x. So x is our independent variable. So that's going to be one side of our table. Now in the middle, I'm going to have the actual rule, y equals -2x plus 1, so I don't forget. And then here at the end, I'm going to have my coordinate point. So this is gathering clues here, okay? So starting with x, whenever you're doing this, you can start with any x value you want. So why not make it a simple one? Now the most important thing to do is always have a negative number, always use 0, and always use a positive number, so you can see what different types of numbers do to the equation. So I normally, whenever I'm graphing, whenever I'm trying to figure out what's happening here, I will always start with a negative number. So I'm going to start with the easiest negative number, which is -1. Then in here, we substitute. So I'm now going to say y equals -2 times -1 plus 1. And what does that equal? Well, I know that -2 times -1 is going to be 2. 2 plus 1 is 3. So when x is -1, y equals 3, meaning I now have 1 point. When x is -1, y is 3. So -1, 3 is one of my points. Now I'll go to the next easiest one. I'll just do 0. I substitute y equals -2, 0 plus 1. -2 times 0 is the same thing as anything times 0 is 0, plus 1 gives us 1. So my next point is going to be 0, 1. When x is 0, y is 1. Let's go ahead and go to the number 1, which is also easy. A positive number now. -2 times 1 plus 1. -2 times 1 is going to be -2. -2 plus 1 is going to be -1. So now when my x value is 1, my y value is -1. And you know what? For good measure, we'll go ahead and extend this out one more. And we will do number 2. When x is 2, y equals -2 times 2 plus 1. -2 times 2 gives us -4, plus 1 gives us -3. And our value is going to be, whoops, that's that last one. X value is 2, y value is -3. Great, now I have my clues. Now I can go on to step 2. And step 2 is to graph the points. I'm going to graph the points down. Now, it's very important here to also think about what was said in our standard. Our standard says, use units here we go, down at the bottom. Interpret the scale and origin in graphs. Okay, well, what's the scale going to be in our graph? Well, the scale in x, all I need to do is get a little bit past -1 all the way to past 2. For y, there's a +3 and there's a -3. So that's sort of what I need to do. So I'm going to make a graph that looks like this. There we go. Oh, I don't think I actually made this long enough. There we go. We'll do that. Okay, so then I say this is going to be 1, 2, this would be 3, this would be 5 up here, this would be 1, 3, 5, this would be -1, -3, -5. This is going to be -1, -3, and on and on and on. Okay, so now let's go ahead and graph. My first point is -1, 3. So when x is -1, y is 3. Okay, there's one of my points. Next, when x is 0, y is 1. So when x is 0, y is 1. When x is 1, y is -1. 1, -1. And 2, -3. 2, -3. I have all of my points. So we can see what that looks like. Now, let's think about it. Is this going to be discrete or continuous? We don't really need to worry about that yet because we haven't quite gotten to it yet. But since this is an equation, it's going to be continuous. We're not talking about the real world yet. We don't know. Any number can go in here. Any number can fit into y. Any number can fit into x as long as it's equal. So this is going to be continuous, meaning all of these points will be, oh, it's supposed to be straight, but they will be connected as a continuous graph. Okay, so now let's get into actually talking about when do we try and decide whether something is continuous and discrete. Continuous and discrete. Okay, so now that we know how to take a function, make it a table, and then make it a graph, let's go ahead and talk about the different types of graphs. So I'm going to go ahead and write a word problem out. A local farmer is making cheese to sell. Two relationships based on his business are shown. Write a function and graph for each. Are the graphs continuous or discrete? Okay, so there we go. That's our word problem. Okay, we're talking about a farmer making cheese. So we have two different relationships that are based on this problem here. The first is that 1 gallon of milk makes 16 ounces of cheese. Okay, that's the first relationship. The second relationship, which I'm going to go ahead and write in a different color, is each whole wheel of cheese costs $9. Okay, so those are our two relationships. So we're going to go ahead and explore each of these relationships. So let's start with the green side over here, where we need to talk about how 1 gallon of milk makes 16 ounces of cheese. Well, we're going to go ahead and do our 2 steps. We're going to do step 1, step 2. Now, before we get into that, though, I want to mathematically write out. I understand that 1 gallon of milk makes 16 ounces of cheese, but we need to sort of make a decision on what our equation, our function is going to be. So let's see. What are you trying to find? You're saying 1 gallon of milk makes 16 ounces of cheese. Okay, so we need cheese and milk to be our two variables, right? Gallon of milk and how much cheese do you make? So let's say cheese, let's say a wheel. We're talking about a wheel of cheese. So my first variable is going to be a W. So a wheel of cheese, the amount of cheese you get equals 16 ounces times milk. So if it's 1 gallon of milk, it would be 16 times 1. If it's 2, it would be 16 times 2. And that's how we find out how much of the cheese we have, which I put as W. Now remember, variables can be anything. You could have used anything for this. That just sort of makes sense in my head. So now we have the milk and we have sort of the cheese, so the weight of the cheese. So I'm going to go ahead and say milk, my M right here, and the weight underneath. And I'm going to make a little table. So let's start with an easy one. When there's 0 gallons of milk, now I don't need to go negative because I can never have negative 1 gallon of milk. If I have 0 gallons of milk, obviously I'm going to be making 0 ounces of cheese. The weight is going to be 0. If I have 1 gallon of milk, which says it right here, I make 16 ounces of cheese. If I have 2 gallons, well, now I know that it's going to be just a multiplication problem. So it's going to be 16 times 2. It's going to be 32. So I'm going to fill in the rest of this chart as 348 and 464. Oh, I'm so sorry. There we go. That's very blurry. Okay, so I have my table set out. Now I'm going to go ahead and make a graph. In my graph, I'm going to need my y-axis to go up to 64. And I need my x-axis to only go up to 4. So I'm going to say, let's do this right here. And there we go. And this is going to be 1, 2, 3, 4, 5. Great. Let's see. 16, 32, 48, 64. So I'm going to go ahead and move that one up. There we go. So now I have a good scale. Oh, can't really see that. Now I have a good scale that I'm working with here. Okay, so now I'm going to take a look And I have to graph each of these. Now, obviously, down here is my milk, and over here is the weight. So 0 is going to be 0. Great, that's my origin. When I have 1 gallon, I'm going to have 16 ounces. 2 gallons, 32 ounces. 3 gallons, 48 ounces. 4 gallons, 64 ounces. And it could keep going up and up and up like that. Now, if we think about the type of graph we're making, come on. There we go. Oh. Focus. Here we go. Come on. There we go. All right. So if we're thinking about the type of graph we have, can I make milk or can I make cheese for a half gallon of milk? Yeah, I could put a half gallon of milk. It's going to give me 8 ounces of cheese, right? I can do a gallon and a half. I can do 18 gallons. I can do 8.1 gallons if I want. It doesn't matter how much. We don't have to count in whole numbers. We're talking about just the amount of milk you put in. So it could be a gallon. It could be 0.8 gallons. It could be 8/16 of a gallon. So this is going to be a continuous graph. It's a continuous graph because there are measurements and we're measuring each of these, right? So there we go. That's one of them. Now let's go over to our other one. For this one, again, we're going to have to make our own equation. So for this one, I need to pick some variables again. Each whole wheel of cheese costs $9. So we're going to be talking about wheels and the amount of money. The wheels and the amount of money we make. So let's go ahead. I already used W over there. So let's just, you know what? I'm going to pick a random one. I'm going to say A. A, which is going to be the cost or the amount of money we make. Oh, there we go. A works for amount. Great. Equals 9, because each one costs $9, times the number. I'm going to use N as number of cheese wheels. A equals 9N. Now I'm going to go ahead and make my table. We're going to go ahead and say, let's say N, A. Okay, so now let's take a look. Let's go with the easiest one. If I have 0 wheels of cheese, my amount of money I'm going to make is $0. If you don't have anything to sell, you don't make any money. If I have 1 cheese wheel, I'm going to make $9. If I have 2, I'm going to make $18. If I have 3, $27, $36. So that's my little graph. Perfect. Now I'm going to go ahead and make my graph. Now my y values are going to need to go up to about 36, right? And my x values are going to need to go up to 4. So we're over here on my x values. I'm going to have 1, 2, 3, 4, 5. Okay, I have a little extra. And this is going to be the number. And over here, I need to go up to 36. So let's see, 9, 18, 20, 36. 27. Do it this way. 9, 18, 27, 36 is going to be up there. And this is going to be the amount of money we're making. Okay? So let's go ahead and put on our numbers. 0 and 0, 1 and 9, 2 and 18, 3 and 27, 4 and 36, which is actually going to be right up there. Now, let's think about it. Is this going to be continuous or discrete? Well, are we selling tiny bits of our cheese wheels? No, it says each whole wheel of cheese costs $9. So you're selling them by the wheel. So I can't figure out what the measurement is if I sell 1.5, because you don't sell 1.5. You sell 1 or you sell 2. So this is going to stay just like that, and this is going to be a discrete graph. So if they connect, it is continuous. If they do not, it is a discrete graph. All right. I'm out of room one more time, so I'm going to go ahead and move to a new piece of paper. And we're going to finish up with our last example here, which is, now that we know how to do that to a function, and what if our function happens to be nonlinear? Everything we've been working with up till this point has been linear. We've had straight lines. We've had discrete graphs that go in order. They go up the same every time. What if that doesn't happen? Well, it's very easy. It's the same thing. The graph's just going to look a little different. And this actually is even more fun. I like this even more than our straight lines. I like seeing some nonlinear functions. So our function here is going to be y equals x squared plus 1. We do the same thing we've done before, which step 1, we need to get our clues, so we need a table. So what we're going to do, like we did before, is we are going to make a 3-column table. We have x, which is our independent variable. Next to our x, we are going to have our equation, which is y equals x squared plus 1. And on the other side, we are going to have our x and y values as our ordered pairs. So now we go ahead and say, okay, like I said before, we want to have our numbers negative and positive. So I'll go ahead and start with -2 on this one. And -2 would be y equals -2 squared plus 1. So what is -2 squared? Well, it's just -2 times -2. Well, -2 times -2 is going to give us 4, positive 4, plus 1 equals 5. So our first ordered pair is going to be -2, 5. Great. Now we do the next one. -1. Y equals -1 squared plus 1. Well, -1 squared is -1 times -1, which would give us 1, plus 1 would give us 2. So this would be -1 is 2. Now we go to 0. Y equals 0 squared plus 1 equals, well, 0 squared is 0, plus 1 is 1. So our next ordered pair is going to be 0, 1. Then we go to our positive numbers. We go to 1. What happens when it's 1? Y equals 1 squared plus 1 equals, well, 1 squared is 1, plus 1 gives us 2. So now we have 1, 2. And let's go with our last one, which is positive 2. Y equals 2 squared plus 1 equals, well, 2 squared, which is 2 times 2, gives us 4, plus 1 gives us 5. Our ordered pair is going to be 2, 5. Now you notice something very interesting about what's happening now. So we go on to step 2, which is to graph. Now we're going to go ahead and put our evidence on the graph. We're going to see what happens. Well, our y values never get negative. So I don't really need a negative side to the graph. So I'm just going to do this, and we're going to go like that. We're going to make a graph like that. Okay? So this is going to be 1, 2, 3, 4, 5. This is going to be -1. Don't really need. -1, -2, -3. This is going to be 1, 2, 3. Okay, let's take a look at what our graph's going to look like. First of all, when x is -2, y is going to be 5. X is -2, y is going to be 5. When x is -1, y is going to be 2. When x is 0, y is going to be 1. When x is 1, y is 2. And when x is 2, y is 5. And you'll see this is a very different type of graph now. Now, again, since there's nothing telling us it's not, we are going to connect all of these. This is going to be continuous because it doesn't say that this has to be a whole number. So we're going to go ahead and draw a line. This time it's going to look, it's not going to be a straight line. It's going to be a curve, which is a nonlinear graph. But it's the same strategy we use to make sure we see that graph. And we've reached the end of our lesson. So for your work now, you're going to do your guided practice, which is going to be PPSE number 15 through 31 odd. Then when you're done with that, you're going to go to your independent practice. And you're going to be doing the 4-4 quiz, which is assigned on your Pearson SuccessNet. Now, remember, this is fun. Have some fun going through those questions, finding the clues, and going ahead and solving your riddle there. All right, that's your work for today. Have a great day, and I will see you soon.